Hi Chem Gang. In this video I'll be showing the solution to Skill Builder 13.7, and in Skill Builder 13.7 we have the following reaction. We have 2 hydrogen nitrates combining with 1 mole of sodium carbonate reacts to produce water, carbon dioxide, and sodium nitrate. So what they're looking for is if we start out with our hydrogen nitrate and we have 27.2 milliliters of hydrogen nitrate at a concentration of 0.135 moles per liter, and it reacts completely with a concentration of 0.112 moles per liter of sodium nitrate, how much sodium nitrate do we need to react completely with the sodium carbonate? So I always like to write down my given data underneath my formula just so that I can kind of keep it clear what data goes with what. And you can see that I am given both my volume and my concentration for hydrogen nitrate, but I am looking for my volume of sodium carbonate. One other given here is the ratio of moles of hydrogen nitrate to moles of sodium carbonate. So for every 2 moles of hydrogen nitrate reacts with 1 mole of sodium carbonate. Now, this conversion factor I might have to flip depending on what my formula is going to look like when I piece it all together. Okay, so it will either be 2 to 1 or 1 to 2 depending on where I need to cancel out, and that comes from the coefficients in front of my reactants here. Okay, one other thing. I am going from liters, or 2 other things, I should say, liters of HNO3, and I'm converting to liters of sodium carbonate. So my formula is going to go by this sort of solution path. I'm going to be starting out with my liters of hydrogen nitrate to find my liters of sodium carbonate. Lastly, in my formula, we always use liters, so I have to convert 27.2 milliliters to liters. And to do that, I divide by 1,000, which is the same as moving my decimal place over 3 places. So 27.2 milliliters become 0.0272 liters of hydrogen nitrate. So I have to make sure I use that amount in my formula. When I go to answer, I'll then have to convert the liters of sodium nitrate back into milliliters in order to answer the question correctly. Okay, now's the time to build my formula. I always start with what I'm given, which is and I'm starting with my liters of HNO3. So that's going to be 0.0272 liters of HNO3. Then I'm going to multiply by my concentration, and my concentration is going to be 0.135, and I'm going to write it as mole per 1 liter of hydrogen nitrate. Okay, so this part of my equation here is what was given to me. So that was my given, which is right here. And the reason why I put liters of HNO3 on the bottom is because I need to cancel those out. So this right here is actually my molarity. Remember, molarity is always moles divided by liters. Now I'm going to use my ratios up here, my 2 to 1 ratio. I'm going to put 1 mole of Na2CO3 on the top because I eventually want to get to my sodium carbonate, and I'll put 2 moles of HNO3 on the bottom, because then my moles of NHO3 and moles of HNO3 here cancel out, leaving me with my moles of Na2CO3. So this is from that conversion factor here. Then lastly, what I'm going to do is I'm going to use my concentration of Na2CO3, and I'm going to do 1 liter of Na2CO3 on the top, so that I can get my final answer in liters, because whatever unit I have on top here is going to end up being what is in my answer, and that's going to leave me with 0.112 moles from this part of my data of Na2CO3, and that cancels out here. So in this dimensional analysis formula, whatever you put on the bottom is going to cancel out the previous units, leaving me with my liters of Na2CO3 in the end, right here. So that is my formula. 1, 2, 3, 4 different components in the end, starting out with what I was given, and then using my concentration ratios, or sorry, not my concentration ratios, my molar ratios, and then ending with the concentration of sodium carbonate. So to finish off, I'm going to multiply across my numerators. So I have 0.0272 times 0.135 times 1 times 1 gives me 0.003672 divided by 1 times 2 times 112 gives me 0.224, and then I'll divide those data points and I get an answer of 0.0164 liters of sodium carbonate, and then I have to multiply this by 1,000 to get my milliliters, and when I multiply by 1,000, that's the same as moving my decimal to the right 1, 2, 3 places. So my final answer is 16.4 milliliters of sodium carbonate. So that's the answer to Skill Builder 13.7. It is quite a long dimensional analysis, but if you start out with what you're given, multiply by your molar ratio as shown in the reaction, and then by the concentration of what you're trying to find, you will end up getting your answer. Thanks for watching. Bye for now.